Before you run GLM 5.2 on a laptop, you need to download the model. The official repository contains 282 weight shards. Together, the safetensor files are about 1.507 terabytes. That is the first reality check. A model can be described as local, downloadable, or runnable without being practical on the machine sitting in your backpack. The word run hides at least 5 different questions. Can the files be stored? Can the weights fit into memory? Can the runtime split them across the CPU and GPU? Can the first token arrive before you lose patience? And can the model continue generating fast enough to be useful? A tutorial can prove the third question and quietly ignore the other 4, so let us build the correct mental model. Large language model weights begin as numbers stored at some precision. More precision means more bytes per parameter. Quantization stores approximate versions of those numbers with fewer bits. 8-bit weights are roughly half the raw weight storage of 16-bit weights. 4-bit weights are roughly 1/4 before metadata and format overhead. That can turn an impossible memory requirement into a merely difficult one. But quantization is compression with consequences. Different formats support different hardware. Some layers may remain at higher precision. Quality can move. Conversion takes time, and the key value cache created while you use the model still consumes memory separately. This is why the model's parameter headline is not a RAM calculator. Another source of confusion is mixture of experts. In a mixture of experts model, only a subset of expert blocks may be activated for a token. That can reduce the computation required for each generated token. It does not automatically erase the inactive experts from storage. The runtime still needs a way to access the weights that routing may select. Think of a giant library where only a few books are opened for each question. Reading fewer books saves work. You still need shelves for the entire collection or a slower system that fetches books from another room. That slower system is offload. GPU memory is fast but limited. System memory is larger but slower. Storage is larger again and dramatically slower. A hybrid runtime can keep selected layers or active data on the GPU while placing the rest in system memory. Some systems can even stream from storage. Technically, the model is running. Operationally, every boundary can become a traffic jam. If each token requires weights to travel through a slow memory path, the GPU may spend more time waiting than computing. If the prompt is long, the key value cache grows. If the operating system begins paging, performance can collapse. If the model is spread across devices with a slow interconnect, the link becomes part of the inference engine. This is why a laptop with a powerful GPU can still be the wrong machine for a giant model. Compute is only one axis. Capacity and bandwidth often decide whether the experience is interactive. Here is the honest feasibility test for GLM 5.2, or any huge local model. Step 1. Inspect the exact artifact, not the marketing name. Check the repository size, number of shards, precision, and whether you are downloading the official weights or a community quantization. For GLM 5.2, the official safetensor payload alone is roughly 1.5 terabytes. That means storage planning begins before inference planning. Step 2. Identify the runtime. Transformers may provide a direct reference path. Optimized engines may add tensor parallelism, quantization support, or CPU offload. A command from one runtime cannot be assumed to work with another format. Step 3. Calculate the memory budget. Include model weights, runtime overhead, key value cache, and headroom for the operating system. Do not allocate every last gigabyte. A machine that technically loads and then swaps under pressure is not a successful setup. Step 4. Define useful speed before downloading anything. Is 1 token per second acceptable for an overnight analysis? Do you need 10 or 20 for interactive chat? Does a coding agent need repeated tool turns where slow generation compounds across the whole task? Step 5. Test 3 measurements. Time to first token. Sustained tokens per second. And memory use at the prompt length you actually care about. A 10-word prompt can hide the cost of a long coding session. Step 6. Compare against the alternative. A smaller local model may finish the real job sooner because it generates faster, supports a larger practical cache, and leaves enough memory for your editor, browser, and build tools. A hosted model may cost money but save hours of setup and waiting. The best model is not the largest artifact your machine can barely start. It is the smallest system that reaches the required quality at an acceptable speed, cost, and privacy boundary. There are still good reasons to experiment with giant models locally. You may need private data to remain on premises. You may be testing inference research. You may have a workstation with large unified memory, multiple accelerators, or cheap overnight batch time. You may simply want to understand the mechanics. But those are different use cases from an everyday laptop coding assistant. And this is where the phrase, "no GPU required," becomes especially misleading. A CPU can execute the operations. That statement says nothing about responsiveness. Removing the GPU requirement can make a demo more accessible while making the generation speed much slower. So if you see GLM-5.2 running on a laptop, ask to see the entire receipt. Which files were downloaded? Which quantization was used? How much RAM and storage were consumed? What was the prompt length? How long did the first token take? What was the sustained generation speed? And was any remote API quietly involved? Those questions do not kill the local AI dream. They protect it from bad comparisons. GLM 5.2 is useful here because the scale is impossible to hide. 282 shards and roughly 1.5 terabytes force us to separate model availability from model usability. Yes, software can distribute weights across slower memory. Yes, quantization can shrink them. Yes, a sufficiently patient user may launch a model on hardware that looks absurdly small beside the original artifact. But it produced a token is a technical milestone, not a purchasing recommendation. The real local model benchmark is whether the complete machine can store the artifact, load the chosen format, preserve the context you need, and answer fast enough that you will use it again tomorrow.